Very good morning, students. Welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, heat. Today we are in the session number 4. Of course, last session of the chapter. So we'll continue where we left in the last class. But before that, just we'll recall what we learned about the heat in the earlier sessions, right? So when you come to that point, first we learn about what is heat, right? Then another important term, temperature, and how to measure temperature, how to measure heat. We come across in further topics, how to measure temperature by using the thermometer. Then we have seen types of thermometers. We have seen different scales of thermometer, like Fahrenheit scale, Celsius scale, Kelvin scale, Römer scale. And also we have seen the relation between these scales. Means we can convert the value of one scale into another scale by using the relation. That also we learned in the first part. Now, when you see the last class, we discussed about the transmission of heat. Very important. Transmission of heat. How heat transmits or travels from one place to another place. So we already discussed that heat always flows from hot body to cold body, or high temperature body to low temperature body, no doubt, right? But there are different modes of transmission. Just like for us, we have cycle, two-wheeler, four-wheeler, bus, aeroplane, boat, ship. All these are called modes of transportation for us. Similarly, heat also having the different modes or different way of transmissions. So one is conduction, which takes place by actual movement of particles, right? Second one, convection, which generally takes place in liquids and gases with actual movement of particles. And third and most important one is radiation, which doesn't require any medium. It will travel through even vacuum also, like our sunlight traveling through vacuum and reaching our earth. So these are the three modes of transmission of heat. I've given so many examples also. There are innumerable number of applications about these three modes of transmission in our day-to-day life. Just to take bowl of water and start heating, and till it comes to boiling, we can see all three kinds of radiations. Conduction takes place. Why? Because the vessel is solid, which becomes hot and gives out makes the water to heat. When water starts boiling from ground to the surface, that takes place convection. Whenever vapors will come after overheating, evaporation, that vapors are because of the radiation. We can feel, we cannot touch it. Sit in front of the fire. During the winter, what we'll do? We'll put some fire and sit there. But the fire radiations will makes us keep us warm. That is a radiation. Right? Now we'll give further today, the last part of the chapter. We'll discuss further about some change of states. Change of state doesn't mean that going from Telangana to Andhra Pradesh or going to Maharashtra or Tamil Nadu. Change of state of matter. Matter will change its state by various means. So this is what we learned in the last class, transmission of heat. The second part is left now, change of state. So transmission of heat, you have seen conduction. So many applications are given. Convection, there are so many applications. And of course, radiation of heat application. The base of cooking vessel are coated with the mud or painted dull to absorb the more heat. White colored clothes are comfortable in summer and black colored clothes are comfortable in winter because white is good reflector. It absorbs a less amount of heat. Black is good observer and good radiator. It absorbs the more amount of heat and keep our body warm. It's commonly you can know. Right? So while transporting the high inflammable substance like diesel, LPG, etc. in tanks, the tankers are coated with a color with a good reflector heat so that they won't go evaporate. Right? Up to that we learned. Now we come to the last part of the chapter. Applications of applications of expansion of solids. See, so expansion means expansion is nothing but change of shape, area or volume, or we can call commonly dimensions, change in dimensions. Whenever a solid is heated, it undergo expansion, either lengthwise, area-wise, or volume-wise, because a solid will have a geometrical structure, perfect geometrical structure. Right? Take one iron rod, measure the length, say 4.8 centimeter. Example, heat that one for some time and measure it. It may increase by 4.9 or 5. That clearly indicates that on heating, solid expands. Not only along the lengthwise, it also may be area breadth-wise and volume-wise also. Right? So where this expansion of solids are applicable for us? Means solid, liquids, gases all expands on heating. But solids only expands 3 ways. Whereas liquids and gases, they doesn't have any shape or size. They undergo only volumetric expansion. The volume only increases. When you heat the water, its volume may increase. When you heat the gas, it may spread and volume increase. But there won't be any increase other place. But in case of solids, there is 3 types of increasing. Lengthwise, breadthwise, volume-wise. Right, that we'll see. Only this further we get in higher class when you go for that. Separately we'll get what are the 3 types of expansions. One is called linear expansion, one is called aerial expansion, other one is called cubical expansion in solids. But here only we discuss about the applications only. Fixing of iron rim on wooden cart wheel. Wonderful to see. If you see closely a wooden cart, some bullock cart or horse cart, if you see the wooden wheel frame is made up of iron. Frame. Outside of the wooden wheel, frame is made up of iron. How they are fixed? I need to understand. Wooden wheel, why they are framed with iron means because to avoid the friction. You cannot run that much speed with the wooden wheel. So wooden wheel is completely framed by iron. Iron wheel. So how they'll do? They'll prepare the iron wheel with the same size and insert into the wheel and they undergo, pour the water. When there is a very hot, when pour the water, it holds the wheel tightly by expansion of solid only. So the wheel is heated, the frame is heated and inserted into the wooden slumber, then they undergo pouring with water so that the iron frame firmly holds the wooden wheel. Riveting a metal plate. Riveting means rivets them. They'll join the joining of 2 metals with a rivet. Instead, not screws, riveting. It's completely like welding, same process. That heating that metal bolt and insert, they pour the water. Now sound will come. So sound will come and that is holds the 2 separate metals. Means 2 separate metals can be joined by riveting process, which is application of expansion of solids. Next, small gap is left while laying the railway tracks. If you really have any railway tracks near you, go and see. between the two rails, there is a gap. They left some gap for every two rails joining. Why? Because in summer, the gap is filled. If you see in winter as well as in summer also, you can find the difference. During the winter, that metal may expand, the iron may expand and come close. How much as per the local condition? What is the, so the gap may not be same, not at all places. If you go to Jaisalmer in Rajasthan, the temperature is summer temperature is 55 or 57. In Hyderabad, it may be 38 or 40, 45. Then where there is a more temperature, the gap between the rails are more. Because when they won't leave the gap, if it's suppose you join them initially. In summer, what happens? There is no place for expansion, so the track will raise. Track will raise and train will collapse. So to avoid that only, they leave the gap between the rails in different places, different. Sometimes what happens? In winter, they contrast again. Summer, they may come close. Again, winter, as per the winter season, for us it may be 10 or 9 degrees. But when you go to same Jaisalmer, minus 10, minus 20 degrees also possible. Or some other countries. So keeping the view of weather or conditions, the gap is made between the two rail tracks. Very interesting. That is one of the wonderful experience application of our expansion of solids. Next, girders are mounted on the rollers by leaving the small space. On over rollers also, whatever they place girders, by leaving space only. Why space are leaving? Because they expand during the summer. Yes, a slack is left by laying the telephone and electrical lines. See, when you go outside, you can see the wires are looking very loose. Telephone wires or electrical wires, they won't keep tight. Why? Because during the winter, they contrast. They may come close. Only initially tight, because of contrast, they may break. So to allow the contrast in winter, the telephone wires or electrical wires or cable wires are tied loose. Right? That is a slack. Slack is left, means they keep loose. A small gap is left between the blocks while laying the concrete roads. Even concrete roads also will undergo expansion. So between the blocks, there is some space. Special glasses like Borosil or Pyrex glasses are used to avoid the breaking of ordinary glass when hot water is poured. Right? When hot water is poured, why this glass will break? Because of the contrast. Hot and cold combination. When hot coincides the cold suddenly, because of contrast, it will break. But there are some glasses like borosilicate that is used in our laboratory, our vessels, lab vessels, and Pyrex glasses are very useful to avoid the breaking. So these are the few examples where expansion of solids is applicable in our day-to-day life. It may be either laying of telephone wires and electric wires, or leaving gap between the two gap between the railway tracks, or it may be riveting of metal plates, or it may be fixing the iron rim to the wooden wheel. All these are directly applicable for the expansion of solids. Right? So solids expands on heating and contrast on cooling. Then anomalous expansion of water. It's a very special property for water which is not there for heating. This water is this application, this use is very much important in our life. See, generally, matter expands on heating and contrast on cooling. But water shows a peculiar behavior. Peculiar is special, unique. When water at 0 degrees Celsius is heated, it contracts and its volume decreases from 0 degrees Celsius to 4 degrees Celsius. At 4 degrees Celsius, water has minimum volume and maximum density. From 4 degrees Celsius onwards, as the temperature increases, the volume also increases. This behavior of water is known as anomalous expansion of water. So, Water has a peculiar property at 4 degrees Celsius. That is very important. Right? So see, 0 to 4 degrees, volume decreases. Generally, should increase. After 4, volume increases. Why? Because that is a special property of the water, which is also applicable in so many our day-to-day applications that will come across in the next class. When you go to the 8th class, the extension part you can come across, right? Now, the last part of the chapter, change of states. Means, there are 3 states of matter so far. We have solids, liquids, and gases. Of course, there is a plasma is there, and one more 5th one also they discovered recently, but not added in the books. Maybe when you go to the 8th, 9th, 10th classes, the states of matter may become 5. Right now, we know only 3. Solid, liquid, gases. But later we come across one plasma state, and 5th state also discovered recently, for which the scientist got Nobel Prize also. Okay, named after him. Another state of matter. But now we'll discuss only about 3. Right? See, what is change of state? Means change of state means solid is converted into liquid, liquid is converted into vapor, again vapor is converted into liquid, liquid is converted into solids. So many ways happens. We can change the state of matter either by heating or by cooling. Right? By cooling or by heating, the state of matter changes. And such change is called as change of state. Clear? Now, when water is heated after some time, it will begin boil. It will then turn into vapor. If solid substance like ice is heated, it absorbs some heat energy and converts into water. When water is cooled, heat is released and is converted into ice. See, all this happens in our house also. This change of solid into liquid, or liquid into solid, or liquid into gas, or gas into solid is called change of state of substance. Any state to any state. All possibility is there. So a substance can undergo a change of state only when heat is either given or heat is taken away from it. Either if you give heat or remove the heat. Only the 2 methods the state can be converted into solid. See here, diagram can clearly explain everything. So see this, everything I understand. First you see top. So heat is absorbed. When heat is absorbed, solid convert into liquid. Still you are heating the liquid, it will convert into gas. So converting from solid to liquid to gas, heat should be absorbed. Right? Then when it becomes gas into liquid, that is, heat is released. Gas into liquid means just condensation. When heat releases, gas becomes liquid. When again heat releases, liquid becomes solid, that is ice we keep in the refrigerator. So by absorption of heat, solid is converted liquid, liquid into gas. By release of heat, gas is converted liquid and liquid into solid. So these are the 2 ways the state of matter can be converted from one form to another form, which is called as change of state. So during this change of state, some terms will come. You can use some terminology for the change of state. The one is melting and boiling points of a substance. Melting and boiling. Take some crushed ice in a beaker. Place a thermometer in ice and hold it upright. Right? As shown in the figure. Like this. Okay. Solid ice pieces kept here and you have to measure with the thermometer. Place the beaker on the stand. Heat the beaker by using the burner. Right? What do you observe? Even though heat is being supplied, temperature rises to 0 degrees Celsius, and when it starts melting, there is no change. Suppose ice pieces are there. Initially 0 degrees. Whenever ice is completely melting also, there won't be any change in temperature. It shows 0 only. Once it completely melted, then the temperature starts reading. Means some hidden temperature is there. So being supplied, temperature still at 0 degrees, and when it starts melting, there is no change in temperature shown in the thermometer until all ice is melted. Complete ice pieces are there, so many. Until all ice pieces are melted, there won't be any change in the temperature. It remains 0 degrees. On further heating, the temperature of water increases to 100 degrees. At this temperature, water starts boiling. The temperature remains constant until all water is evaporated. The 0 degrees is called melting point and 100 degrees is called boiling point, where solid changes to liquid. If you plot a graph by taking heat supplied on x-axis and temperature on y-axis, so you can see here on the graph how the change takes place. See, so heat versus temperature. What here solid, see, up to here solid is completely straight line only. During melting, there is no change in temperature. Means until all the ice is converted into liquid, there is no change in temperature. Again raised. This is also constant till the total water is vaporized. After vaporization, again form into gas. So at constant temperature only there is change takes place. The change takes place at constant temperature. At 0 degrees, ice converts into the water, that is called melting point. At 100 degrees, is converted into vapor, that is called boiling point. Then vaporization. So these changes as termed as two important definitions, which you might have already learned in your regular syllabus also. That is melting point, boiling point, and condensation, evaporation, sublimation, right? So before going for this explanation, let me show you one video, simple video on your related change of states.
Smile and learn.
Oof, it's so hot. Hey there, I'm making some strawberry popsicles. It's steaming hot today, and I really wanted to have one. But for them to stay solid, I'd have to put them in the freezer like these ones and wait for a while. Really? You don't know what a solid is? It's one of the states of matter. Don't worry, I'll tell you all about them right away. Matter, the substance all things are made of, exists in 3 states: liquid, like this strawberry juice, solid, like this popsicle, and gas, like the water vapor coming out of this pot. Everything we drink is in its liquid state. Matter, in its liquid state, takes on the shape of the container and its volume always stays the same. Particles are separated and can move freely. Can you see how they're moving? They look like they're dancing. The popsicles we eat are solid. Matter in its solid state is characterized by having a fixed shape and volume. Particles are held together in an organized structure. See? Lastly, the gaseous state. The vapor coming out of the pot is a gas. Matter in its gaseous state can change its volume and shape, taking up the space of its container. See? Particles are well separated and can move freely. Look, they move like crazy. Did you get the idea? Let's recap a little. Matter exists in 3 states: solid, liquid, and gas. Solid matter has a definite shape and volume. Particles are well organized and held closely together. Liquid matter takes on the shape of its container, occupying always the same space. Besides, particles are separated and can move freely. Gas matter doesn't have a fixed shape or volume. Its particles are well separated and can move freely. That is all about states of matter. Very interesting, isn't it? Well, I'm leaving now. I won't sell any popsicles if I don't. See you around.
That's it. Perfect. They'll be ready in no time. Hey there, I'm making some more popsicles to sell. They taste so good. I'm sure they'll sell really fast. These are ready, see? They've become solid because I put them in the freezer. Have you ever heard of the word
liquid to
solidification?
solid.
It's one of the changes in states of matter. There are more changes, don't worry. I'll explain all about them. You already know that matter exists in 3 states: solid, liquid, and gas. A change in state happens when we heat or cool matter. If we heat solid matter, it becomes a liquid. We call this process fusion. If we heat liquid matter, it becomes a gas. We call this process vaporization. These 2 processes can occur the other way around. This happens when we cool matter instead of applying heat. If we cool a gas, it becomes a liquid. This process is called condensation.
Freezing.
If we
Liquid to
freeze
solid.
liquid matter, it will become a solid. This process is called solidification.
Solidification or freezing. Simple. Please understand everything will be clear.
Oh no, the popsicles have melted. I completely forgot about them. Do you remember how we call the change from solid to liquid? Fusion. When a solid becomes a liquid, it's called fusion. When the temperature of a solid rises, the particles that make up matter start detaching from one another and move more freely. See? Liquid turns into gas when heated. Do you remember how we call this process? When a liquid becomes gas, it's called vaporization. When a liquid is heated, the bonds among the particles that make up matter become more loose, so particles move around freely. What if I cover this pot? What do you think might happen? Water vapor cools as it reaches the lid, and its state changes from gaseous to liquid. Do you remember how we call this process? I've just told you, haven't I? The change from gaseous to liquid is called condensation. As a gas cools, the particles that make up matter start coming closer to one another and move around more slowly. This will continue to happen till matter solidifies completely. I think the popsicles I froze up earlier are just about ready. That's right, I put some popsicle molds in the freezer a while ago. The liquid in the molds must have frozen up by now. The change from liquid to solid is called... Come on, you know this. I told you before. It's called solidification. During the solidification process, the particles that make up matter lay very close to one another and move less and less. These are the changes in the states of matter. Let's recap. If we heat solid matter, it becomes a liquid. We call this process fusion. If we heat liquid matter, it becomes a gas. We call this process vaporization. These 2 processes can occur the other way around. That happens when we cool matter instead of applying heat. If we cool a gas, it becomes a liquid. This process is called condensation. If we freeze liquid matter, it will become a solid. This process is called solidification.
Right.
Now you know all about the changes in states of matter. I hope you find what you've learned useful in class.
Right. This is very good video where you can understand everything. Everything is explained here about the condensation, solidification. One more important word here left is sublimation. You can see here. The solid substance is called sublimate, and the gaseous state of the substance is called sublime. The process of changing a liquid substance into gas state at any temperature below its boiling point is known as evaporation. Some terms will come here. So what is the melting point? What is the boiling point of water, iron, copper, lead, mercury? All are given. Right. So one more word comes here, latent heat. The amount of heat that changes the state of matter from solid to liquid or liquid to gas without constant temperature is called latent heat. So more details about latent heat will come across in higher classes. And last, we can see the specific heat. Generally, when heat absorbed by any body, heat absorbed or radiated by body mainly depends on some factors. That is, Q is directly proportional to mass and Q is directly proportional to change in temperature. Means the heat absorbed or radiated by any body depends on mass. Suppose if you take 100 ml of water, 200 ml of water, supply same amount of heat for same time. So 100 ml of water absorbs more heat when compared to 200. 100 ml water may heat boil also. That is because more water, more mass, less heat absorbed. So like that, the heat absorbed depends on these masses. So from this, we got one formula Q is equal to, Q is proportional to M delta T. We can write. To remove the proportional symbol, Q is equal to M S delta T. But S is introduced here. What is S here? S is equal to Q by M delta T. That is called, Q is called specific heat. The amount of heat required to change a substance from one state to another state is called specific heat. The quantity of heat required to raise the temperature of unit mass of body to 1 degree Celsius is called specific heat, which is measured in calorie per gram degree Celsius. Why? Because Q is measured in calories, mass is measured in gram, and temperature is measured in degree Celsius. The heat unit of the S. S is called specific heat or heat capacity. Right. So more details about the specific heat, how to find out specific heat by using calorimeter and all you come across in your 8th class. So there are some units are given. The calorific value also very important. Calorific value is nothing but the amount of heat released by burning of fuel. See, the calorific value is defined as total amount of heat energy produced by complete combustion of a unit mass of fuel. When you burn the fuel, how much amount of heat is released? For example, our vehicle runs with the petrol. So by burning the petrol, we are producing the mechanical energy. That is having the calorific value. That is our mileage. Mathematically, C is equal to Q by M. Q is the heat produced, M is the mass. Right. So this is about our total chapter. We work on this theory part. Any numericals are there, we'll solve during the revision session. By end of this month, maximum we'll complete our syllabus. The 7th and 8th lessons. We'll start 7th lesson and we'll start working on the worksheets, the levels which are given here. Right. So that's all for today. Thank you, students. Right. Thank you, all of you. Have a wonderful day. Thank you.